Welcome, everyone. In this lesson, we're going to be talking about compound interest, and we're going to see how this relates back to exponential functions, and then we'll get to use our logarithmic functions as well. So let's start with a motivating example. So we're going to suppose that we deposit money into a savings account. And that money we deposit, we're going to call that the principal. So that's the original amount of money that we put into our savings account. And then the idea is we're not going to touch it. We're just going to let that money sit there. We're not going to make any additional deposits. We're not going to make any additional withdrawals. So we're just going to let that principal balance sit there. Well, then, the way kind of savings accounts work is the bank is actually going to pay us for having our money deposited there. So the bank is going to make interest payments into our account at stated intervals. And so when we kind of sign up for our account, the bank is going to tell us the interest rate. And essentially, interest is the payment that we receive from the bank for having our money deposited. And then they're going to pay this at certain intervals. And the interest period, this is the interval between interest payments. So a lot of times banks will do it kind of quarterly or monthly, maybe yearly. So it depends. Sometimes we'll also call this the compound period. Now, where the magic is going to happen is if you let your money sit in the account long enough, well, you're still going to have your principal there. But then if you let the interest sit there long enough, the interest that you have deposited is going to start earning its own interest. And that's compound. That's compound interest. So any interest that you have that was added to your account and then thereafter starts to earn its own interest. That's compound interest. And this is an idea that's kind of, it seems maybe simple, doesn't seem like too much happening, but it's surprisingly difficult for us to wrap our heads around because exponential growth it's kind of counterintuitive. And so I have a little quote here from Albert Einstein. Says the most powerful force in the universe is compound interest. And I hope we're going to see why with these exponential functions. So let's look at a more concrete example. So let's suppose that we deposit $1,000 into a savings account. And the terms of our account state that the bank is going to pay us an interest at a rate of 6% per annum. And it's going to be compounded yearly. So compounded yearly, what does that mean? Well, that means that tells us the bank is going to put the money into our account once a year. So the interest is paid once a year. Now, if it was compounded monthly, well, then it would be paid 12 times a year because there's 12 months. So it depends. And generally the way interest rates are described is with this given as a percentage per annum. And really what this means is the bank is paying us interest at a rate of 6% per year. So this is our interest rate. And we'll see how to use that to calculate the interest payment. And we're depositing $1,000. So the $1,000 here, that's going to be our principal. That's how much money we're putting in. And then we're not going to do anything else for this example. So this is we call our principal. And what we're going to do is we're going to think about how much money are we going to have in the account after 2 years. All right, so let's kind of diagram this out. We'll think year 1. We'll think year 2 or year 0. So we want to think about what we start with. Then year 1. And then year 2. All right. So let's kind of imagine our account as a bucket. And we're just filling it with money. So we have our bucket in year 0, we have our bucket in year 1, and then we have our year 2, our bucket in year 2. All right, so let's start. In year 0, we're gonna open our account and we're gonna deposit the original principal. So we're gonna put some money in here. All right, so we're starting to fill it up, and this is the only thing we're gonna put in. So this is our principal. We want to keep track of that. So that's our initial deposit. So how much money is in our account? What's our account balance at initially? Well, it's going to be this $1,000. Okay. Well then, let's let that money sit there for a year. And what's going to happen is after 1 year, we're still going to have that principal. So we haven't touched it. It's still going to sit there. But now, the bank is going to recognize that we had this amount of money deposited for that whole year. So they're going to pay us interest. So they're going to put some more money into our account. And this is the year 1 interest that we're seeing. So this is our interest payment. All right, so let's figure out how much money are we going to have in year 1? How much money are we going to have sitting in our account? Well, we're going to have what we started with, so the $1,000. But then the bank is going to take the $1,000 that we had and multiply it by that 6%, but we'll write that as a decimal. And so if we kind of do the calculation here, we end up with 1,060. So that additional $60 that we earned, that was the interest that the bank paid us. So the interest here really comes from this 1,000 times our annual percentage rate. Okay, so that's year 1. Well, we're not going to do anything, so we're going to let this whole new account balance sit there. And what happens after another year goes by? Well, we're still going to have our original principal. We haven't touched it. So that's still going to be sitting there. We're still going to have the year 1 interest, so we're not touching that either. So that's still going to be sitting there. But now, the bank's going to recognize that if we go back to our year 1 balance, we had a few things sitting there, and the bank's going to pay us more money. So the bank's still going to pay us interest for the principal that we had. So they're going to pay us some additional interest here. But now there's this new part that wasn't there before. So the bank's going to recognize that we had this additional amount here, and that's going to start earning its own interest. So we're going to have a kind of a little sliver here. And so what happens is we have our principal. Let's kind of look at what's going on. So we're kind of stacking it all up here. So in year 2, we have our original principal. We haven't touched it. Then we also have our year 1 interest. Then we also have our year 2 interest from our principal. But now we have this extra piece. And this extra piece, this is the benefit of compound interest, is because now, going back to year 1, we had this piece of money that wasn't there before. We didn't put that in there. The bank put it in there for us. But now this piece of interest has kind of earned us some additional money. And that's the idea of compound interest. When interest starts earning its own, starts working for us, starts earning its own interest. And so over time, this might not seem like much in the short run, but over time, this really begins to accumulate big time. All right, so let's figure out how much we're going to have in year 2. What's our account balance in year 2? Well, we take our previous account balance, which was this 1,060, and again, the bank recognizes that we had that deposited for the full year, and then it multiplies by 6%, or 0.06. So we have the money that was there, and then the bank gives us 6% of what was there. And so this is our year 2 interest that we get. And we could keep doing this, and we'd see that the account balance is going to grow over time. Now, we want to weight a formula, and we're going to investigate our compound interest formula. We're going to see a few of them. And to get an idea of where this comes from, let's go back to our calculations in year 1 and in year 2. And let's start with year 1. When we look at this number here, we have 1,000 plus 1,000 times something. We can actually factor that into 1,000 times 1 plus 0.06. Okay. Now, what can we do over here in year 2? Well, we can do something similar. We can factor it. So we can factor out a 1,060, and we end up with 1 plus 0.06. Well, this 1,060, this was just the previous balance right here. And we have that factored all nicely. So let's kind of look at that. So we're going to have 1,000 times 1 plus 0.06. And that's just the 1,060. But then we have another factor of 1 plus 0.06 that we multiplied by. And if we combine those, well, this is just 2 copies of 1 plus 0.06. So we could write that as squared. And so it's not coincidence that after kind of 2 cycles of interest payments, our account balance has this squared up here. It's not coincidence that that's happening after two compounding periods. And same thing, after 1 compounding period, even though we don't normally write it, there's a 1 in the exponent position there. And that's not coincidence that that's happening after 1 compounding period. So the idea kind of sets up our account balance formula here for compound interest. And so what we're seeing in our little example is that our account balance was the $1,000 that we had times 1 plus, the interest rate was 6%, but let's just write I for interest rate, raised to the power n. And that's kind of what we're seeing here in our little motivating example. And we can generalize this. So let's look at it. And the I that we're seeing, this I. This is our interest rate per compounding period. So for our little example, that our compounding period was per year. So we really didn't have to do much there. It was just the 6% that the bank was giving us. And then the n value that's up in there in the exponent, that's the number of compounding periods. And so the bank was just paying us every year. So that was just how many years had gone by, essentially. Well, we can generalize this. So the principal amount shows up kind of as that number in front. The interest rate per compounding period, if we want to look at different compounding periods, we just have to adjust this slightly. It's going to be the annual interest rate by the number of interest periods per year. So some common values for M here are going to be monthly, so 12, or quarterly, so 4, things like this. And then the exponent position, if we're not compounding per year, well, we have to make an adjustment there as well. And so it's going to be M times T. So let's kind of look at this formula. So this is going to be our compound interest formula. And the account balance is going to be equal to our principal amount. So that's what we start with. And then all of this has to do with the interest payments that we receive. So we're going to have 1 plus, and then R is going to be our interest rate per annum. So this is how it's normally going to be given. And the one thing, we just want to make sure we write that as a decimal. So the R value normally is given as a percentage. When we use this formula, write it as a decimal. M is going to be the number of interest periods per year. So we'll see things like quarterly or monthly, things like that. And T is going to be the number of years. And we see the variable there, up there in the exponent. And so this formula gives us our account balance after T years. So let's try an example. Let's look at it. Let's look at example 1. And we're going to kind of continue along the lines of this depositing $1,000 into a savings account. And we're just going to look at what happens at the end of 1 year if the bank is paying us 6% interest per annum. And we're going to look at different compounding periods. All right, so when we do this, we want to just unravel what information that we have. So first, we're told that $1,000 is what we're starting with. That's what we're putting in. So that's telling us the principal is going to be $1,000. All right, now we're also told that the interest rate is 6%. So that's telling us R is 6%. But when we use our compound interest formula, we're going to always write this as a decimal. So we'll write that as 0.06. And then finally, we're also told that we're just investigating what happens at the end of 1 year. So we're told our T value here is going to be 1. All right, so let's see what happens with a different compounding schedule. And we'll probably do annually and quarterly, and then we'll try out some other ones in class. So let's look at annually. And what this means is the bank is going to pay us interest one time during the course of the year. So M is going to be 1. Well, then our account balance, if we use this interest formula here, is going to be 1,000 times 1 plus, our interest rate is 0.06. The bank is paying us that one time, so we'll do 0.06 divided by 1. And then in the exponent there, we're going to have M times T. So we're going to have our M value, which is 1, and then our t-value, which is 1. And if we do the calculation here, this is what we've already done. So 1,000 times 1 plus 0.06, which is the 1,060 that we saw. So this formula agrees with what we've done before. Well, now let's try quarterly. So what's going to happen quarterly? Well, the bank essentially divides the year up into 4 quarters, and they're going to pay us interest at the end of each of those quarters. So what's going to happen is the bank is going to pay us interest 4 times during the course of the year. Now, let's plug in and see what we get. So again, the principal amount is still 1,000. We're still putting the same amount in. We're going to have 1 plus. Our interest rate is still 6% per year, but now we're going to divide that by 4. So we're going to divide that by the value of m, how many times the bank is paying us interest. And then in our exponent, we're going to have m times t. So we'll have 4 times 1. And if we do the calculation here, we end up with 1,061.36. So what's the difference? Well, the bank waited until the end of the year to pay us any interest with annual compounding. So we didn't get that interest payment until the end. That interest didn't have a chance then during the course of the year to start earning any of its own interest. With quarterly compounding, well, after 3 months, the bank puts some interest into our account. And so that piece of interest that it puts in has some time. It has 9 months to start earning its own interest. And then after half a year, the bank puts in another interest payment. So that interest payment has time to start earning its own interest. And so the difference that we're seeing here, it doesn't look like much because we're only talking about 1 year, but this difference is because the bank put money into our account sooner, and so that money had a little bit more time, a little bit more opportunity to start earning its own interest. And over time, though, the difference here can add up. Now, what we're going to see, and we'll do this in class, we'll look at monthly compounding and daily compounding. So monthly is going to be 12 because there's 12 months. And then daily compounding, we're just going to assume non-leap year. So we'll kind of keep this simple. So 365. All right, so maybe try those out, but we'll start with those in class. So we'll see you then. Bye-bye.